Okay, we're going to start off. I'm going to talk about the final exam because really all you need to stay here for is for this part. If you have your test and you are good with it, then you don't have to stick around. But I do want to talk a little bit about the final exam. The final exam is mostly multiple choice. All right. There are some problems that are short answer. I can tell you right now I can tell you right now that the short answer problems are going to be me asking you just to evaluate sine, cosine, inverse cosines, inverse secants, inverse cotangent, just evaluating some special angles and inverse trig functions for special angles, things you can do without a calculator. All right, so that's what you'll have to do for short answer. The rest of the test, there's definitely things like exam 5 that we use the calculator throughout the whole test. And so you won't have the use of a calculator on the final exam at all. So there's ways I have to ask you to do some of those things. For instance, let's say that first problem, since you have it. What did you do? You had to use the law of cosines, right? On the first problem? Well, can I ask you to do a law of cosines problem? Yeah. I just may not ask you to evaluate the whole thing. You may have to just leave it as what you would type into the calculator. So it's not that you're not going to have to do anything that you did use a calculator on. You're just not going to have to plug it into a calculator. Does that make sense? I'm trying to think what else we use the calculator on. Doing some of the applications to angular velocity, linear velocity and stuff. Just a bunch of applications problems. You will have application problems on there, guaranteed. All right, so I just am not going to make you use a calculator. Or the angles will be in such a manner that you don't need a calculator. That makes sense? Bring a new AccuScan. Monday, 12:45. A new AccuScan. Don't write your name on it or anything. You're going to scan them all in. I'm going to redistribute them. So bring an AccuScan that you would be proud to give to somebody else. Not the one that's been in the bottom of your bag all semester long. Here's a chance that I can get rid of it. Don't do that to Rebecca. You have until Sunday night at midnight. Well, really, when I come into work on Monday, you have until I come into work on Monday to do any MyMathLabs that you haven't done yet for half credit. So any extra stuff you want to do any problem that you haven't done yet, you can still get half credit on it until I finalize your MyMathLab grade Monday morning when I come into work. And then you can't change anymore. I think I have all of y'all's grades up to date except probably the MyMathLabs. I don't think I updated those. I can do that right after class today. I'll update the last MyMathLabs and MyMathLab quizzes. Get those in eCampus.
Yeah, I think the worksheets and the test is all you do. So,
yeah, I forgot to do that. I can do it. Do y'all have any questions about the final exam? What to expect for next week?
Is there any, between the 5 exams, is there any of them that you're going to harp on a little more closely?
I wouldn't say so. It's pretty evenly distributed.
Okay.
Have you written it? If I have the final exam, it is done. It is printed there under lock and key. You'll never find it.
Password.
34.
34, you got it.
I've never heard of that.
No, you're not.
They cracked the code.
On your deathbed.
On my deathbed. said, all y'all are gonna come back and go.
Bring you a jersey.
We're in Jersey, and I'll be like, careful.
Someone get a jersey.
Actually, that reminded me of something. The final exam replaces your lowest exam grade, right? So most of you understand how that's done from the previous semester, but Philip, how that is you're going to have 5 major exam grades, and then the 6th major exam is going to be final exam. I dropped the lowest one of those. So everybody's final exam is 20% of your grade, for sure. Oh, show. All right, but most of you, well, I shouldn't say that, many of you will replace your lowest exam grade or a missed exam grade with the final exam grade. I think that y'all can do well on this final exam. I really do. I don't think that it's particularly hard. I mean, it's not easy because it's over the whole semester we did a lot of stuff. But a lot of the stuff we did, I mean, we built on each other. I mean, if you don't know what cosine of 2 pi over 3 is by now, you're probably not here. And all of y'all are. So, some of you are like,
34.
34.
Negative 34.
Negative. No, half credit. All right.
Do we get bonus points if we write like them in different quotes?
Maybe, you never know. You never know.
I have a TSA average.
Chicken fried steak's my favorite.
Yeah, chicken fried steak.
I like Double Dave's.
What a burger. Ooh. I'm hungry. I haven't eaten lunch. What?
I haven't eaten breakfast.
Oh, that's worse. Oh, yeah.
Well, at least it's not bad chip day.
Yeah, well, I don't even know what I'm going to do. I don't even know what I'm going to do. I don't know.
I wouldn't go over there.
I'm not going to go over there.
It's crazy. There are a bunch of snot-nosed high school kids over there. It's horrible.
Where?
Over at the student center.
Well, I don't know what I'm going to do.
Where?
I'm going to eat at like 1:30 and I was going to throw everything off.
Double Dave's is just right across.
I know. And all the 8 miles for nothing. All right. Well, any other questions about the final exam before I get to answering questions from other stuff? I'll put the solutions to exam 4 on eCampus. Exam 5 on eCampus right after class. I was going to do that before class, but got to run in late because I was running. And so they'll be up there. But I will answer any questions right now over exam 4. Ahora.
Exam 4 plus
Exam
1.
5, whatever.
If that's what you want.
Exam 5.
If you want to make exam 5, the final exam.
You'd be fine with that?
I went to.
I mean, considering that one exam will be dropped, and this would be the 4th counted exam.
So, what you're saying is just take your grade for exam 5 and have that as a final exam?
I would actually.
That would be great. Unfortunately, I might get in a little bit of trouble for that.
We won't tell anybody.
Yeah, it's true.
Nothing.
It's true. There's no way.
The government,
Like, that was the hardest exam ever.
will come in and will be fine.
Your rate, my professor average will go up above Miss Miller's.
And that is my goal.
How can you turn that down?
Here.
It actually put like a major part of who I chose my professor
It
for this
has the
semester.
person's name, date of birth, their social security, and the dates of service that were requested for their record. So,
All day is access.
that
I was the quiet one that had.
Do y'all have any questions from exam 5?
Yeah.
Okay.
I knew one person that I actually got. Like, I know this person.
Because I had no.
They're an accident. I didn't call and ask them. I
need
So I have to wait for.
Again, everything that I do on this exam 5, I will post this on eCampus.
She's on her way.
Yeah,
What do you got?
this one.
What do you got? What questions? 4?
I didn't do this. I didn't find one of these in this first.
Oh, you did it? What'd you do?
I just drew the line
Oh,
and
that's
made it
on
right.
page 4.
I made this half.
I literally, I didn't know what to do.
All right, a plane flew due north at 500 miles per hour.
I'll just figure out the side.
Second plane started at the same point and at the same time flew at the bearing of 150. So if it's flying due north this way, 500 miles per hour, it went for some distance, I don't know. And then at a bearing of 150 degrees. So if we're talking about from due north, 150 degrees is going to be all the way around over to here. Now, how long are these? Well, let's see, 3 hours is what they traveled. So the distance that the northbound plane flew, I'll say distance 1, will be, here, you know what I'm going to do? I'm going to call it A. The distance of A is going to be 500 miles per hour times the number of hours, which is 1,500. And B, that is going to be the speed, which is 435, times the time, which is 3 hours. And that is 1305? 1305?
Yeah, 13.5.
Okay. So now we are going to find how far apart they are. So what is this distance? I'm going to call it C. Well, what does this angle measure? 150 degrees. 150 degrees. So to find out C, I know the two sides and the angle between them, that's the law of cosines. So C will equal the square root of A squared plus B squared minus 2AB cosine of the angle between them, which is, well, I'll just write 150 degrees. I didn't call it anything. It's gamma. So this is the square root of 1,500 squared plus 1,305 squared minus 2 times 1,500 times 1,305 cosine of 150. And I think plugging that in my calculator, I get, I don't know.
You get A.
Yeah, that sounds about right.
I figured I would do.
All right. Did you put, I don't know what you could have done.
I did not.
Bad bearings?
No, I didn't extend the magnitudes for the 3 hours of travel.
Oh, you did 500 and 435.
Rookie mistake.
Don't do that. Don't do that. All right. What else we got? What? Anything from this test? Yes, Turbeck. 3. All right. Cell tower. Now, there's kind of 2 ways to do this. Cell tower stands between 2 observers that are 565 feet apart. The angles of elevation at the top of the tower are 32 and 46 degrees from the observers. So there's 2 observers here. One makes an angle of 32 degrees to that tower. The other one is going to make an angle of 46 degrees to that tower. So here's the 2 observers, observer B and observer A. And the tower, I don't know the height of that tower, do I? That's what I'm trying to find, its value h. But I do know that this whole distance from here to here is 565. I also know that this angle measure here is 32 degrees. I know that this angle measure is 46 degrees. So I know 2 sides of this triangle. Oh, I want to say one other thing. I have 2 right triangles in here, don't I? So I know this whole side. Do I know the angle opposite that 565? Yeah, it's going to be, I'll call it, I don't know, gamma. It's going to equal 180 degrees minus 32 minus 46, which would be, okay, I'll believe you, and 102 degrees. So I can solve for this side or this side, doesn't matter. And if I know either one of these sides, then I can find h from either one of these right triangles. So which one do you want me to solve for? Do you want me to solve for B, or do you want me to solve for A? I should have done that in green, huh? Which one do you want me to solve for?
A.
Okay, I'll solve for A. So the law of sines says sine of 32 degrees over A will equal sine of 102 degrees over 565. I'm going to cross multiply 565 sine of 32 degrees equals A sine of 102. And so A will be 565 sine of 32 degrees over sine of 102. So that's A. And whatever I get for A, fantastic. That's it. I'll approximate it for you. I'll put it in the calculator.
I got 306.1.
I believe you.
That's right.
I do believe you. I just want to show everybody how we're putting it in. 565 sine of 32 divided by sine of 102. Now I need to make sure that I'm in the right mode. I'm not. Somebody's changing my mode up on me. 306.1. Now I'm not going to use that approximate value. I'm going to use that exact value when I solve for H. And so I know A. That means I know sine. I know sine of 46 degrees is the opposite side, H, over A. So A sine of 46 degrees is H. So I know A. It's about 306.1. And so I'm going to use that exact value times sine of 46. And I get an H of 220.2 feet. Rebecca, I think you just, I remember yours. You missed it because you did something weird here. You just got a wrong answer for some reason. You must have typed in the calculator wrong. I remember that because I was following your work and I was like, you're doing everything right. I circled something, right, on your page? I remember it now. So you did everything right. You just, I don't know how you got the answer that you got. Do you know how you got the answer you got? What I circled? I don't know. I don't know. You did it. You did it pretty good. You just, something weird happened with yours. All right. What else? No, that's not right. That was on I didn't grade this. That was on the last page, second to last page, the one you missed. Because that's the one that I graded by hand. Something I circled. Do you see what I'm talking about? What I circled, you did right. I mean, you just got a wrong answer somehow. You typed it in the calculator wrong. Type it in the calculator again, see if you get it right. What was the problem? 10? 10.
10. I know.
Okay, to find out if vectors are parallel or perpendicular, there's a little, shortcut to that. If the dot product of the two vectors is equal to 0, what does that mean?
Perpendicular.
If the dot product is equal to 0, then what that means is that the cosine of the angle between them would equal 0. And what value would make that equal to 0?
90.
What angle would make that 0? 90 degrees. So that means it's perpendicular. All right. Now, if the dot product equals the product of the magnitudes or the opposite of the product of the magnitudes, then they're parallel. But, I mean, going through that whole process, you're going to have to find the dot product and the product of the magnitudes anyway. So I'm going to find the dot product of these two vectors first. So no matter what you do, however you do this problem, you always have to find the dot product and the product of the magnitudes. So let's just find them. The dot.
You have to find the magnitude if it was perpendicular.
Oh, I'm sorry. If it's perpendicular, you just find the dot product. So you have to find the dot product. Let's find the dot product first. Then if it's not 0, then we'll go on. You're absolutely right. So the dot product of these two vectors will be 20 times 5 plus negative 8 times 2, which is 100 minus 16, which is 84. Okay, so so it's not perpendicular. That much we know. Now the magnitude of this vector, the magnitude of this first vector is going to be the square root of 20 squared plus negative 8 squared, which is the square root of 400 plus 64, which, let's see, this probably 16 goes into that about, let's see, this is probably about 4 square roots of 30 something. 16 goes in that
29.
29?
Yeah. I just did the calculator. Not my head.
16 times 29 equals that?
Yes, 16 times 29 is 464.
I believe you. That's, all right, so the magnitude of the other vector, 5, 2, is going to be the square root of 5 squared plus 2 squared, which is square root of 29. So the product of these two vectors are going to be 4 times 29. Is 4 times 29 84? Is 4 times 29 equal to 84? No. I mean, 4 times 21 is 84. So I know right off the bat it's not parallel either. However, I mean, we can find out exactly what it is by saying cosine of the angle between theta. I forget if I use theta or alpha for y'all, so I've wrote it both ways. 84 over 4 times the square root of 29 times the square root of 29. So that means that theta is equal to inverse cosine of 84 over 4 times 29 would be 4 less than 120, which is 116. No, 116.
That'd be 80 plus 36. So,
Yeah, that's another way to do it. So I don't know what it is. It's something. It's definitely not right angle or 90 degrees or 180 or 0. What is it?
46.
Sure.
43.6.
43.6 degrees. So definitely not any of those. Neither. It's pretty much the same problem that you had, I think, on the previous page. Find the smallest positive angle between W and Z. You just didn't actually have to do everything if it was parallel or perpendicular. All right, what else? If you want to go, you can go. You're not going to offend me. I mean, go do what you got to do. This is all recorded too, so if you miss something or if you forget something, or if you just miss my voice.
We're gonna download all the integrities to our.
8.
You haven't checked my grade worksheet for.
I know I haven't. I really haven't. I really didn't know that, but keep reminding me after class. Remind
Maybe
me.
you should sign up for this reminder.
Yeah. What? Wait. Somebody said something. 8. Am I just making this up? Did somebody have a question? Anything from exam 5? Okay. How about exam 4? Let's go backwards. Exam 4.
we pretty much took care of that yesterday.
No problem on exam 4? Are we looking at it still? You do have a question, Philip?
Just saying, I'm reviewing my.
Okay.
Number 12, exam
Okay.
4.
The solutions are up, but I'll go through whatever problem you're doing. Exam 4. I'm sorry, which one was it?
12.
12. Okay. If I just see sine and cosine all by themselves, I mean, that's a big hint to me that I'm going to try to make this into.
That's not the total I have.
It's not the 12 you have?
Yeah, I'm sorry, I'm on 3.
Okay. Then I won't do this. It's a big hint that's going to be tangent or cotangent
Yeah.
to finish up that thought.
Can you look at the workout?
Which one?
The workout problem,
The what out?
14 to 15.
Two portions.
14, 15. On these? On the calculator part?
Yeah.
Okay. So, I'm going to isolate the cosine of 2x by subtracting the 1 and dividing by 4. I'm getting it right to here. And I'm going to say, hey, look, I need to find 2 points. I need to find any point on my unit circle that has an x value of negative 1/4. Well, negative 1/4 is about right there, so up here and down there. These are my 2 angle measures. Now, if I do inverse cosine, I'm going to get that guy. So how do I get the other one?
Subtract it for you. Yeah.
What?
Nothing.
Okay. I can just take the opposite of that cosine, inverse cosine, right? It's not going to give me the smallest positive one, but it will give me that angle measure. So, 2x will equal inverse cosine of negative 1/4 plus every 2 pi k. Or 2x equals negative inverse cosine of negative 1/4 plus every 2 pi k. So, dividing everything by 2. Don't forget to divide that 2 pi k by 2 also. Will give me these values. And I think I wanted all the solutions from 0 to 2 pi, right? So I'm going to start off with 1/2 inverse cosine negative 1/4. Start off with a k of 0. Oh shoot, I gotta change my mode. So x will be 0.91. If I add pi to that, is that still between 0 and 2 pi? I mean 0 to 2 pi. Is that between 0 and 2 pi? Certainly is. 4.05. If I add pi to that, is that between 0 and 2 pi? Definitely not. I've added 2 pi to my previous answers. That's definitely going to get outside of 0 to 2 pi. And the other one, negative 1/2 inverse cosine of negative 1/4. Now, if I have a k of 0, this is going to give me a negative value. And we expected that to be the opposite of what this one was. So this is not on my interval. I need to start adding pi. Add pi to that. Hey, 2.23. Add pi to that. 5.37. And so here are my 4 values. How's that look, Adam? Like trig. You know what you can do over the holidays, Adam? Not just you, Adam, anybody. You can take this problem right here, this exact problem. Maybe when you're around family, maybe Christmas morning, after all the presents have been opened. And you say, hey guys, I want to show you something. This is what I've learned. You do this problem, and it looks really smart, right? I mean, that looks like a really pretty smart problem, doesn't it? I mean, it's to somebody that doesn't know trig, it looks like really smart. And then you impress everybody. You're like, I'm learning something. This is how I got all of my friends. Math.
Unless you have siblings who are math majors and then they're just like, ha ha ha, I'm in Cal too, shut up.
Yeah, well then don't do this.
Yeah.
Don't do this. You're not going to impress them at all.
Here, let me show
But
you.
you know what you might do to them
What?
is quiz them over their trig identities, and you may know more trig identities than they know.
I was told over the Thanksgiving holidays that they do hardly use trig at all.
Well, that's not true at all.
That's just what they were.
That's not true. They just don't know that they're using their trig. They're using is just they've used so much. They're just like, oh yeah. it's some of those trig identities are very rarely used. I readily admit it when we learned it, but you do need to learn them and at least be aware of them. But some are used a lot.
Yeah, now they said there was like specific ones that they use like all the times, but then most of it it was like on a very rare occasion. You had to
Like,
look up at something.
I'm not certain. Yeah, I'm not certain I've ever used the tangent of a sum identity beyond my trig classes. Probably haven't. But you're learning all the other ones. You might as well learn that one.
My younger brother who's at the University of Texas, brought his girlfriend who's also a math major. Yeah, I tried. He thinks we're cultish. I couldn't deny it. So, yeah, I got schooled by both of them on the difficulties of the calc because I was complaining about trading.
Tell them.
Yeah.
Just what you need to do. Just get an A in Calc 2. Then go back and tell them what's up. There you go. Just do it just like that. How about them apples? That always gets them.
They come back with 52.
Yeah, and then you
Yeah.
just keep getting better and better.
It's okay, because we're going to divert in the majors, so then I just throw engineering on them.
Or just tell them that they're getting a subpar education, and you won't be lying. You can see.
I got you.
All right, what else you got? Anything for exam 4? All right. Well, if you think of something,
Know all of them?
exam 3. What?
This is 4. Know all of them?
Know all of your identities. Any identity that you've learned is fair game. And I shouldn't have said the tangent of the sum identity is not useful. Because then you might think that isn't something that I would ask on a final exam.
And it'll be there.
It could be there, all right? Yeah, 3 times. You have a question, Megan? On exam 3 or exam 4? All right, 20.
While you're flipping there, you were talking about all these identities.
Mhm.
The half-angle identities, because we didn't really use those in the test.
Well, the half-angle identities are the what most people, I guess, would refer to as the power-reducing identities, and you did use that on the test. But well, I'll get to that in a second. Let me do this problem, and then we'll get back. All right, top of the building, spectator watches a hot air balloon rise from the launch side. So we have this building here. Oh goodness, I better do something over here. We have a building. It's 110 feet high. 110. Spectator watches a hot air balloon rise from the launch site. The spectator measures the angle of depression for the top of the building lights to the launch site to be 14 degrees. So this is the horizontal, and so this angle is 14 degrees. 5 minutes after the launch, the spectator measures the angle of elevation to be 61 degrees. So angle of elevation now, 61 degrees. 5 minutes after the launch. How high above the ground is a hot air balloon 5 minutes after its launch? Well, how high is this? So there's our hot air balloon right up here. This is the ground, launch site.
110 plus H.
And so we have this distance right here is 110, right? We need to know what this distance is. And the total height will be x plus 110. Well, I know that I have 2 right triangles actually. Right triangle here. I'm going to call this, I don't know, D, for the distance between the two, or the building and the path of the balloon. Because I can find out D from inverse tangent. Tangent of 14 degrees is 110 over D. So D, tangent of 14 degrees is 110. D is 110 over tangent of 14. So we find out that it's approximately what? Let me change my mode. 441.2 feet. Now, to find out x, well, that's going to be tangent of 61 degrees is x over 441.2. So just multiplying 441.2 times tangent of 61 degrees, that's going to be x. I'm actually going to use this value times tangent 61. So x is 795.9. So the height of the balloon is x plus 110. So that would be, what is that, 905.9 feet? 110, 805, 905.9. Look good? Why's everybody so quiet?
Absorbing.
Yes.
What page in the notes is the identities?
It is 653. Yours is.
I know, I just want to get close. All right, here, half angle identities, absolutely. We didn't go over them. They are just the these power reducing identities with the square root. That's what they are. And the square root property. And instead of an x here and a 2x, you put an x here, and this is 1/2 x. But no, we don't go over them. We didn't go over them. Thank you for bringing that to my attention, though. Not that they're bad. Just you use this more than you'll use this.
No, I'm good with using power reducing.
Okay.
We had not really.
You're absolutely right. That you could scratch those off, but don't scratch them off because you may want to know them sometime. But you do know them if you know this. What's up? What else? Anything from? All right, let's go to exam 3. You had a question from exam 3, so I will go ahead and insert that. Exam 3. And that was number 12.
See? You can't go nowhere.
All right, so what do I want to do? Just simplify it into one trig function?
Yep.
Okay, so what I'm going to do is I'm going to split cosine squared into 1 minus sine squared, theta. And then I'm going to factor that numerator. That is going to be 1 plus sine, 1 minus sine. And I have a 1 plus sine of theta in the denominator, so those cancel. So right now I have 1 minus, and in parentheses, 1 minus sine theta. So I got to distribute that negative to both terms. So this will just be sine of theta.
Wow, I made that way harder than it was.
Probably so.
I'm sure you remember.
The only other way I think it's reasonable for you to do, maybe getting a common denominator, but still that's it's going to make your life hard. If you multiply by 1 minus sine over 1 minus sine, I mean, it's probably a longer way of getting there, but yes, you will get there. But it's only going to involve Pythagorean identities.
$16.
16. All right, a lot of stuff here, right? A lot of stuff. Well, let's first write all these in terms of tangents and hopefully try to get the same angle measures in here. All right, tangent of negative 20. Well, tangent is an even or an odd function?
Even.
Odd. The only one that's even is cosine and secant. So it's odd, so this will be positive tangent 20 degrees. Now, I don't have an identity with cotangent here, so how can I change that to tangent? Well, it is a cofunction. 90 minus 50, which is 40. Hey, that's good. So now I got 20 and 40 here, and I can probably make that 40. So this is going to be 1 plus, well, I'll leave tangent 20 alone. And to make tangent a positive 40, then I'm going to change the sign out here. So now I have the tangent of a sum 20 plus 40. Tangent of 60. And tangent of 60 is square root of 3. I don't know if the culprit is still in the class right now. I don't remember. But I do remember somebody got negative square root of 3, and you got almost 0 credit for it because everything else to get up to that point was completely wrong. Just in case you're out there and you're wondering why. All I did was get the negative. Because you got there completely wrong. If you got to here, tangent of 60 degrees, and you wrote negative square root of 3, I probably didn't take much points off at all. But was it you, Adam? Was it you?
It was.
Was it really?
Because I remember getting this one wrong. I was like, that has to be right. And I did in my head where it was like 40 and 50 or something together. I forget really, but I was like, that has to be.
I mean, I think maybe somebody got the square root of 3 right, and they're wrong, and I gave them credit. I reluctantly gave them credit, I believe. So maybe that was you, Adam.
I don't really remember. I don't know where my exams are.
They're filed under T for trigonometry.
13.
You don't have that system?
Yeah,
Oh, you do?
definitely not.
Okay. What else we got on? Anything from exam 3? Anything else from exam 3? Before I move on. 12?
20.
20.
Way off in the right field with this thing.
Yeah. Yeah.
This is the one who taught us how to work wrong in class.
I was lenient on this. I was very lenient on it because I told y'all incorrectly how to use the power reducing identity.
So correctly now.
I was very lenient on this problem. So sine to the 4th is sine squared all squared, right? So what is the identity, the power reducing identity for sine squared?
1 minus cosine 2x over 2, all squared.
All of this squared. 1 minus is the difference between cosine squared and sine squared here. 1 minus. So now I need to square the numerator. Squaring this numerator is going to give me, well, what?
1 plus 2 cosine
1
2
minus
Yeah,
2
minus.
cosine 2x
plus
plus cosine squared of 2x all over 4. Now, I'm going to, we want to write this, the powers of trig function no higher than 1. So I don't want a cosine squared here, so what am I going to do with that cosine squared?
rewrite it again.
Yeah, I'm going to write this using the power reducing identity again. So this is cosine squared of 2x. So the power reducing identity for cosine squared is cosine squared this time
1 plus cosine 4x.
is going to be 1 plus cosine twice this angle, which would be 4x this time, over, shoot, not 4, I'm looking at 4, 2. So this is 1/4 minus 1/2 cosine of 2x plus, all right, 1/4 times 1/2 plus 1/2 cosine 4x. So 1/4 minus 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x. And I can combine like terms. This will be 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. Pretty lenient on this grading this one. Somebody in the class, I'm not going to name names, did it exactly wrong as I did it in class. I'm going to name names, did it perfectly wrong as I showed you how to do it in class. Completely ignored the fact that I told everybody that I did it wrong and sent out a text message.
Twice.
Yeah.
That was whenever you were harping on Albert.
Because he worked it for me and then turned around and after he told me, yep, that's the right answer, I went back down there, started working. I'm like, something don't look right. Hey, look back at this. Dang it.
And you know, it's one of those moments that I have no idea what was going through my head. Like, I was like, yeah, I can do this. No, I can't. This is made up some rule.
I had a
no
couple
idea
of
what.
those. I had a couple of those on this last test.
I hate it. I hate it when I see it from y'all, and then all of a sudden I do it.
It's like dividing by the square root.
It's like, you know what? You know what'll aggravate every single math teacher in the history of math teachers, or anyone that's good, is if you decide that you're gonna find this and you're gonna say it's a squared plus b squared. No, don't ever do that. Don't ever do that. Or similarly, that's not true. Or similarly, saying, oh, look at that, I just cancel off one of those, and that's a plus b squared. No. All of those things will drive a math teacher insane.
Wouldn't that be a plus b squared over a?
Yep, you could do that. Basically, I'm saying you can't cancel off a factor.
Right, you'd have to split it into
Yeah,
two terms.
You can factor out a factor in the numerator. Then cancel. But anyway, that's enough of that. Anything else from exam 3?
No.
Exam 2? Now we're getting into the ones y'all didn't really.
The inverse. I got confused yesterday. I was looking over some of this. When you do an inverse function, tangent, sine, whatever,
Mhm.
if it's, say, pi over 4, inverse sine of pi over 4,
No.
can't do that?
Inverse sine, it will be of a ratio. The
Oh.
outputs of inverse trig functions are angles. So if you look in here, what you input into an arctan or inverse arc cosine, inverse sine, these are the ratios. The values of x or y are the ratios on the unit circle. What you get out is angles. So inverse sine of pi over 4 doesn't make, you actually technically can find inverse sine of pi over 4 because that's a number between -1 and 1, but it's kind of gibberish. It's not what you mean.
That's actually the one I was talking about, but I looked at the answer after I started reading it.
This answer right here, we're saying where on my unit circle on these two, in these two quadrants from -pi over 2 to pi over 2, do I have a y value since it's sine of negative square root of 2 over 2?
And it's in 4,
Well, that's right here at that angle measure. And what's that angle measure?
negative pi.
Negative pi over 4. That's the answer.
Okay, that's.
Not inverse sine of pi over 4.
Right.
Sine of negative pi over 4 equals negative square root of 2 over 2.
Okay.
Megan,
Number
10.
10.
Can I do this in our new way with the right triangle trigonometry? Because that's the way I prefer to do it anyway. Because if we're going to say alpha equals arctan of x over 2, that means tangent of alpha equals x over 2. So guess what? We can make a right triangle. And this is alpha. The opposite over adjacent is going to be x over 2. If I'm going to find cosine of alpha, I'm looking for the adjacent over the hypotenuse. So what is the hypotenuse here? The square root of x squared plus 2 squared. So cosine of alpha, bless you,
Bless you.
cosine of alpha is going to be the adjacent over the hypotenuse. And I don't know if I told you to rationalize the denominator or not. If you rationalize the denominator, this is what it is.
So actually, some of our newer stuff makes our old stuff even easier.
Okay, I'm going to show you how I did it real quickly, the older way, and you'll see that it's really the exact same thing. It's just, instead of finding, the three sides of a right triangle, you're finding X, Y, and R, right? So at this point, we weren't saying opposite over adjacent, we were saying Y over X. And over here, we wanted not adjacent over hypotenuse, we wanted this to be X over R. So Y was X, and this gets confusing, X is 2, and we need to know R. Well, R squared equals X squared plus 2 squared. R equals the square root of X squared plus 4. So we come over here and we say X is 2, R is the square root of X squared plus 4, and we get to the same thing. It's just using X, Y, and R rather than adjacent, opposite, and hypotenuse. When I learned this, and the way I've used it my entire life since then, I've always changed this to right triangle trigonometry. So teaching it with X, Y, and R is very frustrating for me through this whole thing, but it's fine. It's good. It's valid and it's worthwhile because then you really have this understanding of these ratios. They're not just, sine, cosine, tangent. All the trig functions are ratios of X, Y, and R. The X, Y point on the terminal side for that array and then the distance from the origin. Anything else from exam 2?
Number
19. We are finding the vertical asymptotes. So, vertical asymptotes for secant. We're going to find out where cosine crosses the midline, right? So, what we can do, we can say this is equivalent to y equals 2 cosine of x over 4 plus 1. All right, where does this cross the midline? Well, cosine starts at the top or bottom of the wave, right? It doesn't really matter when we're finding the vertical asymptotes for secant, because if it starts at the top or the bottom, it's still going to cross the midline at the same values. So we need to go 1/4 of the period to the right of where the cosine starts to find our first vertical asymptote. Well, do we have any type of horizontal shift, phase shift? No. Do we have a period change? Absolutely. Our period is 2 pi over b. Our b here is 1/4. So our period will be 8 pi. That's the period of this function. So to find the vertical asymptotes, we need to say that, well, they're going to be x equals, since there was no horizontal shift, then we just start off with nothing, but we add 1/4 of the period to find our first vertical asymptote. And then how often will they occur? Half the period. Okay. So x will be 2 pi plus 4 pi k. Now, is this the first non-negative vertical asymptote? If I subtract a 4 pi, I'm negative. And yeah, this is good. The amplitude has nothing to do, the vertical shift has nothing to do with it. Just the horizontal phase shift, the phase shift and the period. And that's kind of like the hardest type of problem, I guess I could ask in terms of finding the vertical asymptotes, because inverse or cosecant, you don't have to worry about the phase shift. Right? Well, you do worry about the phase shift, but you don't have to go 1/4 of the period to find the first one. You just do the phase shift. That's it, and then plus half the period, because sine starts on the midline.
How come you switched to cosine?
I just wanted you to see that I'm thinking more so of cosine here. Where does cosine cross the midline? not secant. When I graph secant, I'm actually graphing cosine and then taking the reciprocal of everything. Right? Remember when I graphed secant, I actually put the points, and anywhere I crossed that midline, that was a vertical asymptote. The top and bottom of the waves, and I just created a little parabola-like shapes.
I'm just thinking like, if you switch it from 2 secant to cosine, wouldn't that be 1/2 cosine?
No.
Or not?
Okay, I'm not switching that to, I'm not trying to write an equivalent
wait,
expression.
I remember.
I'm using cosine to graph secant. I know what you're thinking. You're thinking if you had cosine of like 2x equaling 1/4. No, if you had secant of 2x equaling, 4, then cosine of 2x equals 1/4, right?
Yeah. I remember now.
Yeah. All right. How about exam 1? No? Yeah, you probably know most of that stuff, besides maybe the application stuff.
But then it's just like refreshing on
The formulas for
I think we,
angular velocity, linear
Can we get a
velocity.
bunch of those kind of questions? That'd be
Bunch
great.
of these. Where's the angle?
Where's the angle? Where's Waldo?
Well,
I might have a chance of-
I told you you're going to get a lot of questions just basically like this. I mean,
what page is that?
Blow it up, please.
which one is that?
It's 72.
just evaluating trig
Oh.
functions and reciprocal trig functions and inverse trig functions. I mean, I could absolutely ask you cotangent pi over 6.
How much will I need to be on the exam?
They'll be on there throughout, periodically. Yeah. I mean, we even used identities in other sections too when we solved equations. We used identities. That's pretty much it, right?
How many questions?
20 total questions.
How many of them are applications?
I don't know. Some. There's definitely a few.
And there's short answer, mostly Scantron, a few short answer.
The short answer ones I told y'all are evaluating trig expressions, reciprocal trig expressions, and inverse trig expressions.
So it's not like word problem?
It's not a word problem. Now, don't think that you're not gonna. You're having word problems,
Yeah, but there'll be multiple choice.
but it'd be multiple choice. So, well, the reason I even tell you that is I don't want you to think, oh, well, if he asks me what sine of 3 pi over 4 is, I'll have some options there to pick from. No, you're going to need to know those. That's what that is.
We need to study the trig application equation.
Let me also say that the multiple choice problems, it's going to be fairly difficult for you to look at the answer choices and be like, oh, well, I'm going to guess this based on the answer choices. You're going to have to know what you're doing. Don't rely on, I'm going to just plug all this stuff in and see what works approach. All right.
Don't Charlie out.
Yeah. Well, you can Charlie out if you want. But
You told us last time that the answer is C.
an answer,
The last
how about this? An answer will be C.
I feel much better.
Okay. I can't really back that up right now, but I'm probably so. The probability that there's not a C is very low.
Too dang high.
So what you got? Anything from exam 1?
No.
Anything from anything? Y'all had a review, right?
What time is that test on Monday?
12:45.
12:45?
Final exam review. Anybody started that?
I printed it.
Well,
Does that count?
hey,
You know what you should do?
printing's half the battle. Isn't that what the saying says? Sure.
Sure. You need to create a file and you can't miss this says final exam reviews. And then when you click it, it just does the rickroll.
Ah, that's pretty funny. My office mate, he created a under his content exam solutions. He put solutions to final exam solutions. And you click on it and scroll down and it says, "Just kidding." So I thought it was pretty funny. Where's exam 4 solutions? Oh, is it up?
It's right there.
That's exam 1.
Yeah.
Oh,
They're out of
oh
order.
shoot. No, they're not. And I'll put exam 5 down there too. Y'all want the old exams, blank exams?
Yeah.
I can do that. Where do you want them? Where do you want them? Here? I'll put them in there.
You're talking about the,
Just blank copies of the exams that we took this semester. 1414 exams? Why
Wow.
is it up at 1414? That's weird.
I'd rather not.
Exam 1.
Philip might need a few of those, but I think I'm good.
It won't let me do multiple of them.
Just give it almost a-
I don't know what kind of psychosis I was under whenever I thought that doubling up 1414 and plain trig was going to be a good idea.
1414 is a difficult class. There's a lot of stuff that you do in 1414. It is a lot of stuff that you have to do. There's a lot of stuff in 1414.
Is there more stuff in 1414 than the calculus class?
There's more stuff in 1414 than there is in Cal 1.
Is Cal 1 just integral?
No, actually, it's mainly derivatives. It's
That's what I
a tad bit of integrals. I'm teaching Cal 2 for the first time next semester, so
Everything is just building
pretty
blocks.
excited about
So
that. Yeah, well, everything you learned in 14.4, everything you learned or learning in 14.14 is there for a reason.
building blocks. That's why the next it's smaller, but it's like there's more to it.
The number one reason people fail Cal 1 easily, is not knowing their algebra and trig. Calculus is not that difficult.
Mine would be very frustrating.
People not knowing their algebra and trig. Mainly not knowing the algebra, but trig too. I mean, anyway.
I guess the trig is more word problems. Is that true?
No, it's like, all right, you're going to, at some point in time in your calculus class, you're going to have to do this. You're going to have to, oh my goodness. You're going to have to solve this equation. All right? You're going to have to. And if you can't do that, then you're not going to be able to answer the question, and you're going to get it wrong. You're going to miss the whole problem because you don't know how to do trig. But you could have done all the calculus right, but you can't solve this equation because you don't know trig. And also, at some point in time, you're going to have to say, oh, cosine squared of x. Oh, I know what that is. That's 1 plus cosine 2x over 2. And if you don't know that, you cannot do the problem. You just cannot do it. So,
What is
speaking
it?
of integrals, I mean, if you know an integral, this is where you're going to do that. You're going to see a problem that looks just like this, and you're going to have to go to there. That's the first step in the problem. If you can't do that first step in the problem, you can't do anything.
So what is a derivative?
And you'll learn all about that. It is an instantaneous rate of change. That's what it is.
What was the hardest math course you took?
The hardest math course I took was probably a class called complex analysis. It's basically, it sounds kind of smart, but everything that you learn in calculus, you have to prove, and then some stuff beyond that, and some more like theoretical stuff. It's a lot of proofs. I mean, I remember studying for an exam, and it was just a bunch of proofs, and the teacher told us, there's 10 proofs. 5 of them are going to be on your exam. And so you just learn all, and I remember being in the library, writing down the proofs over and over, not for like rote memorization, but like understanding, the logic of going from here all the way down to here. And each one of them was like a page or 2 pages of just writing stuff. It's interesting though. It's like a puzzle. But it's pretty cool.
Is the one nice thing about math is that it's very logical. So you can,
Absolutely.
even if you don't fully understand, you're like, all right, so I'm here, and I have to get to here, and so there's only so many things I can do.
But if you truly understand it, I mean, if you truly understand everything that you're doing, it makes perfect sense. There was a long time of my mathematical career where I just followed the rules. You tell me what to do, I'll do it. And I didn't understand what I was doing. And I regret that. Like, I wish I would have known more of what we were doing than just how to do it. But that was because I went to a school where everybody took a calculus class, and so the calculus class was not as rigorous as it is at a bigger school. Like, a lot of people here can take business calculus or engineering calculus. They're significantly different. Where I went, there was kind of a middle ground calculus that that everybody had to take. All right. Well, I mean, if you got any other questions, I'll answer them. I'm here. If not, I'm gonna go find something to eat.
I'm gonna go to Casa Rod's.
Ooh, get an El Mobley. You get them? You ever got El Mobley? Just the queso on the
I've
fajita meat,
had it, but I
right?
usually get that La Montana.
Oh, wait.
It's basically nachos, but it's got extra stuff on it.
Really?
Extra stuff.
Yeah, it's got like fajita meat. You can get chicken or beef and beans and cheese, and it comes on the big flour tortilla
Oh, yeah,
sticks,
yeah.
the homemade ones.
I like me some casserad.
Oh,
You know what I like better than casserad though? Papa Perez.
no. Dude, I'm ashamed.
And the exam goes to 12:30, you said?
The exam,
The final exam goes from 12:45
12:45 to 3, but
it won't take that long.
many people will get done a lot quicker than that. You have that amount of time, but and maybe some people will stay here 2 hours and 15 minutes. And that's perfectly fine. I mean, I'm in no rush. I got nowhere to be, but it's not a 2 hour and 15-minute exam. You should not feel rushed through this. All right, I'm gonna stop there.